Assalamu alaikum students. Today we are going to start with the formation of insoluble salts, and we will learn that how the insoluble salts can be formed and what would be the method that will use to prepare a insoluble salt. So start with the insoluble salts. For this, you have to memorize the solubility rules. Out of many, we have the list of insoluble salts. If we are starting with the chlorides, then in chlorides, the insoluble salts are silver chloride, lead 2 chloride, and mercury chloride. And for sulfates, we have barium sulfate, calcium sulfate, and lead 2 sulfate. Talking about carbonates, all carbonates except group 1 and ammonium. These are insoluble, and if we are working with the hydroxides, so all hydroxides except group 1, calcium, barium, strontium, and ammonia, they are insoluble. Now we will see that how can we able to prepare an insoluble salt. Insoluble salts can be prepared by ionic precipitation. Insoluble salts can be prepared by ionic precipitation method. So what is ionic precipitation method? How it can be used to prepare an insoluble salt? Ionic precipitation method refers to like we are using two soluble salts. Two soluble salts means we will mix the two soluble salts that will result to produce one soluble salt and one insoluble salt. So what would be those two soluble salt that we will mix together to produce one soluble salt and one insoluble salt? Those two soluble salt contains the cation and anion of an insoluble salt. As we know that the salt is formed by the combination of cations and anions. So positive and negative ion will when combined together to produce a salt. Now we will see that what would be the two soluble salts means one contain cation of insoluble salt and the other contain second contain anion of insoluble salt. Suppose we are going to produce silver chloride, which is insoluble salt. In order to produce that silver chloride, we have to find that which soluble salt will give us the silver cation and which soluble salt will give us the chloride anion. So talking about the silver salt, we know that all the nitrates are soluble. So for this one we will use silver nitrate, and then we will add sodium chloride because sodium chloride is soluble in water. Now we will cross multiply, means silver cation will react with the chloride anion and sodium cation will react with nitrate ion to produce the two salts. One will be silver chloride and the second one will be sodium nitrate. It is clear that all the nitrates are soluble or all the sodium salts, as you are already aware of from the solubility rules, that all the nitrates are soluble, but the silver chloride is insoluble salt. So over here we have found that an insoluble salt has produced and this one is a soluble salt. Now we can write it in the form of chemical equation because this one is a word equation. So the word equation, from the word equation we will produce its chemical equation in the symbolic form. Now silver nitrate formula is AgNO3 aqueous and sodium chloride is NaCl aqueous. Now sodium ion will combine with nitrate and silver will combine with chloride ion to produce silver chloride AgCl solid plus sodium nitrate NaNO3 aqueous. Silver chloride will produce white precipitate. White precipitates means white solid particles will produce in the mixture. Now we can also share the ionic equation from this chemical equation, symbolic equation. We can also write the ionic equation that you have already learned in your previous lessons. So we can split aqueous one in the form of the ions, like from silver nitrate we can write the silver ion plus nitrate ion plus sodium ion plus chloride ion. The solid, liquid and gases, they will not be converted into ions, so they will remain as it is, while the sodium nitrate will also dissociate into ions. Now the substances that remain unchanged on both sides of the equation, they will be cancelled out, like the sodium ion in the aqueous form and the sodium ion in the aqueous form, nitrate ion and nitrate ion. They will be cancelled out because they don't play any role in writing the ionic equation, because they are spectator ions. Now the net ionic equation will be the silver ion will only combine with chloride ion to produce our resultant product, silver chloride precipitates. We can take another example, and it could be barium sulfate. Barium sulfate is also an insoluble salt with the formula BaSO4. Now, from the formula, it is obvious that we need only two ions to produce the barium sulfate, and the ions are barium and sulfate. From this, we can say that, like, we are using barium nitrate plus soluble sulfate. We can use the sulfates of sodium, potassium, because the salts of group 1 and ammonium are soluble. So we can take the sulfates from these substances, or like sodium or potassium sulfate, we can choose sodium sulfate Now, what would be our products? Barium sulfate and sodium nitrate. In this way, you can write like barium sulfate will produce and sodium nitrate will be our byproduct. We can transfer this word equation in symbolic form. Barium nitrate BaNO3 twice aqueous plus sodium sulfate Na2SO4 produced barium sulfate BaSO4 solid and sodium nitrate NaNO3. We will see that whether this equation is balanced or not. Over here we have the two sodium atoms, but on the product side we have just only one atom of sodium. In order to balance it, we will multiply it with 2. So by this we can write a balanced chemical equation for the above reaction. In order to write its ionic equation of precipitation, previously you have learned that we can write the ionic equation by cancelling the spectator ions, but ionic equation of precipitation can be written in another form, like just mention the precipitate that is producing during the reaction. Over here the precipitate is of barium sulfate. I am writing the precipitate on product side, barium sulfate solid. Now guess what? What two ions that are producing the barium and barium sulfate? So those two ions are barium ion and sulfate ion. So your net ionic equation you may write in this form, net ionic equation of precipitation, like write the precipitate first that is producing on the product side, and will observe that what two ions are producing this precipitate, we will write those ions on the reactant side in aqueous form. Another equation of forming the barium sulfate precipitate we may write in this form, like we are choosing a barium salt that can be barium chloride, barium chloride, barium chloride plus sulfuric acid H2SO4. Sulfuric acid is also a soluble substance, so sulfuric acid, we may also use sulfuric acid. So over here barium ions react with the sulfate ion to produce barium sulfate, white precipitates of barium sulfate. Plus hydrogen ions will react with the chloride ions to produce hydrochloric acid. In order to balance the equation, we will write to HCl. So over here we are writing that in above reaction sulfuric acid is reacting as a salt but not as a acid. Because we have already learned that the sulfuric acid is a salt, but this is not a typical reaction of sulfuric acid. Typical reaction of sulfuric acids are acid plus metal oxide, acid plus metal hydroxide, acid plus metal carbonate. But over here acid is reacting with the salt, which is not a typical reaction of acid. So this is ionic precipitation, and here the acid is acting as a salt but not as a acid. Next we are getting another example, and that is that belongs to the previous one that we have learned for the ionic precipitation, or the testing or identification of cations. We have left with the colorless. We had already done the colorless cations identification. Now today we will see the colored cations, the identification of colored cations, and identification of colored cations will be in the form Over here we will write the reagents, then copper ion, iron 2, chromium, and lastly we have iron 3. Reagents, so copper, cation, iron 2, chromium, and lastly we have Fe3 positive. Over here we will see like what are the particular tests of these cations that we have already learned. Now there were the two reagents that you have already used, and those two reagents were aqueous sodium hydroxide and aqueous potassium hydroxide. Aqueous sodium hydroxide and aqueous ammonia. I repeat, aqueous sodium hydroxide few drops. We are adding the few drops of aqueous sodium hydroxide, and for the copper 2 ions, blue precipitates will produce. Blue precipitates formed. In case of iron 2, green, you may write dirty green precipitates. But in the form of chromium, green or grey green can be mentioned. Grey green precipitates formed. And in case of iron 3, we will write reddish brown precipitates produce. Next, aqueous sodium hydroxide in excess. Now we will add aqueous sodium hydroxide in excess. So for the copper 2 ions, precipitate insoluble. Over here for iron 2, precipitate insoluble. For chromium, precipitate dissolve to produce green solution. But for iron 3, precipitate remain insoluble. Next, now the second reagent we will add in the second portion of the solution. Add few drops of aqueous ammonia. We are going to add few drops of aqueous ammonia in the second part of the solution, and for copper 2 ions, blue precipitate produce or formed. Over here, green precipitates produce. Again for chromium ion, green precipitate produce. For Fe3, we will write reddish brown or brown precipitate produce. When we are going to add ammonia in excess, add aqueous ammonia in excess. So when we are going to add aqueous ammonia in excess, we will found that blue precipitate dissolve to produce deep blue solution. Precipitate insoluble in case of iron 2 and precipitate soluble, but over here precipitate remain insoluble. Now this is the information that you have to memorize for the identification of copper ion, iron 2, chromium and iron 3 ions. Over here we will see that what could be the formula of the precipitates that are producing for copper 2 ions, for iron 2 ions, for chromium 3 ions, for iron 3 ions, and what is the name of that those precipitates. So on the other page we are just writing the name and formulae of the precipitates that are producing for these substances. Now if for the copper 2 ions means if copper ion, suppose we have copper 2 sulfate, copper 2 sulfate solution, copper 2 sulfate, and we are adding sodium hydroxide in it because our first reagent was sodium hydroxide. So what will happen? Sodium sulfate is producing and copper 2 hydroxide. So over here we are writing copper 2 hydroxide will produce along with sodium sulfate. Now this copper 2 hydroxide has the formula CuOH twice, and these are the blue precipitates. Means this is the formula of the blue precipitate and the name of the blue precipitate is copper 2 hydroxide. Similarly, we can write the precipitation equation for this reaction. So you may write the ionic precipitation equation for blue precipitates, ionic precipitation equation, and it is copper hydroxide, copper 2 hydroxide we will write on the product side, and which two ions are forming copper 2 hydroxide. One is copper ion, Cu2 positive aqueous, and other is hydroxide ion, OH negative aqueous. So over here how many hydroxide ions are? 2. So in order to balance we will write 2 on the reactant side. This was related to the identification of colored cations plus the formation of insoluble salt. I am going to write for you the recap of this lesson in the form of the table that we will practice, that what kind of the products that will appear when the two substances will mix and what can be the formula of those products. Over here, the first thing I am writing the solutions that mix together. Solutions mix together. Now formula formula of precipitate produce. Next is name of precipitate produced, and lastly color. The first one, we will write iron 2 sulfate and sodium hydroxide. Second one, lead 2 nitrate and potassium chloride. Third one is dilute sulfuric acid and barium nitrate. We can take another example, the fourth one, last one, and it can be aqueous ammonia and iron 3 chloride. Iron 2 sulfate reacted with sodium hydroxide. Obviously, the formula of the precipitate will be iron 2 hydroxide, FeOH twice. Its name will be iron 2 hydroxide that precipitate will produce, and its color that you had already learned, its color will be dirty green or green. Now when lead 2 nitrate is added in potassium chloride, so over here an insoluble salt will produce, which would be lead 2 chloride. Lead 2 chloride formula is PbCl2, and it will form the white precipitates. Dilute sulfuric acid added in barium nitrate, we had discussed it with the equation or with the example like dilute sulfuric acid when added in barium chloride, but over here another soluble salt of barium, we had used barium nitrate. So over here the precipitate will form barium sulfate, so name is barium sulfate, and it will also result the white precipitate. Lastly, aqueous ammonia and iron 3 chloride, again the identification of iron 3 ions. It will produce iron 3 hydroxide, iron 3 hydroxide, and iron 3 hydroxide formula is FeOH thrice. This iron 3 hydroxide will produce the reddish brown precipitates. So students, this was all related to the identification of cations and the formation of insoluble salts. Hope your all the queries will be cleared and your misconceptions are clarified in this video. Thank you.